In this video, I would like to discuss about neural networks for predicting a health-related outcome in Python. Neural network is a computational model inspired by the structure and function of biological neurons. At a high level, a neural network consists of interconnected nodes uh, organized in layers, and information flows through from input to output. So it consists of things like neurons that connects and the layers and the weights and the activation function. Activation function basically converts linear output to some restricted output. For example, if we need data in 0 and 1, between 0 and 1 we use sigmoid function, and for different ranges we can use different type of activation function. So in this tutorial I will just show how we can apply a simple neural network with a few layers and different number of neurons, and how we can predict a classification problem, a binary variable, using a set of covariates. I'm not going in detail about the about different aspects of neural network. So we will again start with the Framingham heart disease dataset, chronic heart disease dataset, which is I already downloaded it in my computer, and we can upload it here, and then we can run this dataset. This consists of different demographic and clinical characteristics of patients and the chronic heart disease status, 10-year CHD. This is our study variable, and we want to predict the CHD status of different individuals based on the dataset on different demographic and clinical characteristics of the patients. So first we need to check the number of missing values in data set. For example, we just run df is null and then sum. So it will give the sum of missing values in all variables. Can just check there is no missing value in gender variable and age variable, and education variable we have 105 missing values. In cigarette per day we have 29 and then 53, and in glucose we have 388 missing values. So we you have already a tutorial on I have already published on YouTube a tutorial handling data and feature engineering. You can watch this tutorial to handle this. I have just replaced the values with mean and mode for the mean for the quantitative variables and mode for the qualitative variables. Uh, for example, these are the quantitative variables, and now I think we have replaced all the values with the mean for these variables: education, cigarette, and uh, blood pressure, and then total cholesterol, and then BMI, and then heart rate, and then glucose. So we can now we need to extract our data. We just drop the y variable from our data set, and then keep all other uh, variable as predictors, and then we take the study variable 10-year chronic heart disease, and then split the data into test and training based on 20%, keeping 20% as test set. And then we can see the shape of all the variables: x train, x test, y train, y test. Now we are going to build a model. We are using the TensorFlow package, and then Keras models, we are importing sequential and then dense. So this is used for a sequential neural network, which work in sequence. First one layer, then other, without skipping different layers. And dense means we have many nodes on a single layer. And then here we are setting up the structure of our neural network. We have four hidden layers with a number of nodes: 128, 64, 32, 1. You can keep any number order for the number of nodes, but you, I always recommend to keep the number of hidden layers in a descending order. That will give you, that will not lose information. If you keep, for example, this layer small and this layer large, then some information will be lost. So, and then model compile, we use optimizer. This is ADAM, is an optimizer used in neural network. And then binary cross entropy is used as loss function, and the metrics we are using for performance there is the accuracy. And then we get the model summary. Just run this. This is the model summary. This tells about the, this is a full dense layer, and this is another dense layer, this dense layer 2, dense layer 3, and these are the output shape, means number of nodes, outgoing nodes from a layer. And then these are the total number of parameters we need to estimate on one layer. And we have total number of parameters 12,000 something, and trainable parameters that are used in train dataset. All the parameters are used in train dataset without skipping. So it's the non-trainable parameters are 0. There is no trainable parameter. And then we build the model. We can just skip this, and you can check the history of the model. Now we are fitting the model. Basically, these are 3 inputs, 4 inputs: X train, Y train, and these are epochs, and this is a validation split. At each step, we are using a validation split. We are testing. We are again dividing the data into test and training for to check the results, predictability of the model at each epoch, at each epoch. So we have total 100 epochs. So we get these results. You can see accuracy at each epoch and the loss, and then value of accuracy and value of loss. So now we will just use the fitted model for prediction. This is used for basically setting the hyperparameter. I am skipping the choose of a hyperparameter step because it's time taking task. So you are just going to set it to build a classifier. So we are again using the TensorFlow model and Keras layer, and then Keras classifier. Classifier just we used in a random forest classifier, SVM classifier. So we need Keras classifier that is used for classifying the new data set in neural networks. So just build classifier with these parameters. We need an optimizer, learning rate, activation, and as far as you keep a higher learning rate, it will learn quickly, but it will lose some efficiency, the predictive ability. And this is the activation function we use. And and this is number of neurons. This is number of neurons on second layer. This is number of neurons on third layer. And the classifier is sequential, and we need to use the classifiers for all four layers. This is the number of neurons 1, number of neurons 2, neurons 3, and then on the final layer we have only one neuron, and the activation function is used as sigmoid. So if optimizer is ADM, optimizer ADM, then set your learning rate, and if else you will use uh, a root mean square proportion, RMS proportion, and then compile the optimizer, and this is by we are using the loss function as cross entropy, and the matrix is accuracy, and then you will get your final classifier. Think we have not run these packages. We need to check if we have skipped any classifier above. Um, we have skipped our model parameters. Then we can should run clearest classifier is not defined, it's not uh, updated. So this package is not installed. The Sai Keras. So we can try to install this here. PIP. It is installed now. So now it should work. Yeah. And then these are the parameters we are going to keep. We are setting the number of neurons on neuron layer 1, and number of size of neuron on layer 2, and size of neuron on layer 3, and then model activation, that is we are using ReLU and 10 hyperbolic, and model optimizer we are using these two optimizers, and model learning rate, these are three different learning rates. So we use these to uh, select stable hyperparameters we can check for these different sets. So let's see for the above classifier, we can get the predicted y values. These are 0, 0, 0. And now we can just perform the check the accuracy of the classifier we have. So accuracy score, y test, and y prediction. We can find the precision score, we can find the recall score, we can find the F1 score, and we can find the confusion matrix. So this is the confusion matrix. These are all the layers we get. So this is the classification we get, and this is true positive and true negative, and these are false negative and false positive. This is false negative, this is false positive. So this is the performance of the model, and you can I always recommend to tune the model before going to the final prediction task, as it is required for prediction, for a good prediction. And then we can see the plot for different number of epochs, how accuracy is changing, and then set a final epoch for your analysis. So for this, we are importing matplot library PLT, and then Seaborn. From Seaborn, we import Seaborn imported as SNS, and then we set the figure size, and then uh, subplot within the plot, and the history, that is accuracy, and this is just like a histogram, then like a time series plot. And then these are the two labels for x-axis and y-axis, accuracy and epoch. This is accuracy and this is training accuracy. These are two values, these are two history. And then the value accuracy and validation accuracy. These are the values, these are the labels. And then this is the title, this is X label, and this is Y label. So you can see the training performance and validation accuracy for different number of epochs. Uh, Wherever you get maximum accuracy, you will stop your you can set that epoch as the best epoch. For example, you can see for epoch number of epoch, I think 80 or 75, we get highest accuracy. So this is to be set as new epoch when you are working on your model. Similarly, we can see the loss versus epoch. This is just the inverse of this. This is accuracy and this is loss. So loss is decreasing and accuracy is mostly increasing. So you can alternatively we can see the loss of the model with the number of epochs. I think this is not run. You should run first this, and then you should run this one. Now it's working. And then as we did in other machine learning algorithms, we can find the heat map for confusion matrix. We can just update this. Now we get 9 observation, 120 observation, 9 and 720 observation. So this is uh, almost a good predictive model with almost 80% accuracy. So missing values should be imputed before going to the analysis, and the data was separated into test and training. A sequential neural network model was built with 3 dense hidden layer using ReLU activation and output layer with sigmoid. So these are some key points about our analysis. And you just need to see the recall score, F1 score, and other performance measures for comparing between different models. Thank you. If you have any question, you can always write in comments. This is not an exhaustive lecture on neural networks. This is just a basic of neural networks, how things work. So if you want more extensive knowledge of applying neural network to your real data, then you need to know about more about the neural networks and its different terminologies. Thank you.